So in this problem with Regina, she's trying to create this circular cage. So what I think about when I do this, I think about first, okay, I got a circle, and she's trying to put the wire along the edge of the circle. So I think about what am I trying to find? Well, if I'm putting the wire along the edge, that means what I'm finding is the circumference. And I know that the circumference is equal to the diameter times pi. Now, when she says that she bought 50 feet of wire, I have to think, does that represent what I can use to create the circumference, or is that what's used to create the diameter? In this case, I think about the wires, what's going along the edges here. So what that represents is my circumference. And what I want to find about being the widest uh, that our circular cage can be, that's my distance across the circle. Well, the distance across the circle that goes to the center being the widest is my diameter. So what I'm really finding this problem is the diameter. So if I plug in 50 equals d times pi, well, I know that pi is just a number. That's one of the things to remember. It's a constant. So I can divide both sides by pi. And when I do that on the calculator, depending on the calculator you have, you may not have a pi button. If you don't, you can use our approximation of 3 and 1400ths. And if I use that, either way, whether I used the symbol pi or I used 3 and 1400ths, I'll get very close. I'll get within 100th of one another. If I use just the approximation, I get 15 and 92 hundredths. Instead of using this equal sign, what we really should use is the approximation sign. So that means that the widest my circle could be, or the diameter of my circle, would be 15 and 92 hundredths feet. So just under 16 feet wide. And if I use the pi, I would get it would round up to 15 and 92 hundredths as well. All right, so the next problem here was about the Thomas family and their circular flower garden. So here's one that you've got to be very careful about what is going on in this problem and how do you draw it. So I'm going to use circles. So first thing I have is a circular flower garden. Okay, so here's my circular flower garden, and I know that my diameter is 14 feet. And I know there's my radius, right there, my center right there in the middle. Now the thing I have to pay attention to is they want to put a 2-foot brick walkway around the entire bed. So that means I need to create a larger circle that goes around this entire bed. Now you can see I'm off a little bit, so let me move it up a little. That's pretty good. So now what I'm really looking at is this idea, here I'll use the highlighter, is this idea of, well, I want to create this around here. So if we think back to the idea of like the additivity principle, what we have is this really big circle, and what we want to remove is the little circle from the center to figure out that area of that walkway. Now here's where you've got to be very, very particular about what's going on. So let me change back over to my pen. And that's what is the area, or the diameter, I'm sorry, the diameter of my large circle. And that diameter, I have to remember, it's not 16 feet, it's 18 feet, because I have 2 feet of the diameter to the left side and 2 feet to the right side. And what a lot of people forget is they'll forget that second 2 feet when they're looking at the diameter. So what I want to do to figure out the total area of my square bricks, I would say I want the area of the bricks. That's going to equal the area of the big circle minus the area of the small circle. Now, area of a circle, remember, is pi times the radius squared. So I think about my big circle, my radius is not 16, it's or my diameter is not 16, it's 18, which means that my radius is 9 squared times pi, and my small circle is 7 squared times pi. So you got to remember that, again, that diameter is going on both sides, that extra 2 feet. So here I have 81 pi minus 49 pi, which is going to give me 32 pi for the amount of bricks. Now, that's kind of a funny, and that's in square feet, kind of a funny measure to have. So what we would do is we would approximate that. And again, you can either, if you do 32 times the pi symbol on your calculator, or if you use 3.14 or 3.1415, you'll get very close, and you'll get that this is approximately 153 hundredths square feet. Now, the second part of the question then asks, well, what would be the cost? Well, the cost is the cost per 1 square foot times the total number of square feet you have. So, I know that I have 153 hundredths square feet, and I know that I'm being charged $3 for every square foot. So, if I multiply them together, I would get about $301.59. So your answer should be somewhere pretty close to that. Maybe a little bit depending on your rounding as to how far it went, but again, money goes to 2 decimal places, so even if it was 60 cents, you'd want to make sure you put 6 and 0. Okay? All right. So the next one asked here about the pizza shop and trying to break even, so that we want to make sure that we charge enough that we aren't losing any money. So the first thing to figure out is, well, how much does it cost per square inch? And once you see per square inch, that should ring a bell that you're dealing with area. So let's highlight. So we know that we have 5 cents for the dough, 3 cents for the sauce, 2 cents for the cheese. So I know that my cost per square inch is equal to 10 cents. Now, how do I get 10 cents? Well, if I add those 3 values together, that's 10 cents for the total cost per square inch. So now I need to go each pizza. So I know that if I have a 12-inch pizza, first thing I have to figure out is, well, what's my radius? I know that my radius then would be 6 inches, and that's needed because I know that area is the radius squared times pi. So that gives me 36 pi, which is approximately 113 900 square inches. So I think about, well, if I want to make sure that I cover my costs, I need to take, this is how many square inches I have, and the cost is 10 cents per square inch. So if I multiply them together, I know that I would take my 113 900 square inches and multiply that by my 10 cents per square inch. And you see that's how my units cancel. And that tells me that my pizza should be about $11.31. So if I sell it for at least $11.31, I will at least break even, and that's the important thing. So I can use the same mentality to find the 14-inch pizza. Let's see if I can put it all here. Here I know I'm going to put my radius over here of 7. So I know that my area would be 7 squared pi. This is 49 pi, or approximately 153 and 9300 square inches. So that means if I'm looking at my cost, I'm going to be taking that 153 and 93 hundredths square inches and multiplying it by that 10 cents per square inch. Again, my square inches cancel, which leaves me with that cost, and that would be approximately $15.39 would break even for me, approximately. It's not exact, but again, because we're changing the approximations of pi. All right, so there we have our pizza. The last problem on here dealt with the Ruiz family wanting to build this brick patio and trying to figure out, well, how much will it cost them? So the first thing with a problem like this is to figure out, deal with the radius and figure out where your radii, your circles, your rectangles, what do we have here? So we got to use that additivity principle. So if I draw in my pieces here, I see that what I have are two semicircles and a rectangle. And I can verify where the diameter that I just drew that line should be based on my radius, because I know that the radius, because it's a semicircle, the radius has to be the same no matter where I am on the circle. So I would want to make sure that if I went this way or to the left or to the right, that it's always the same. So I can see that my radius here would be 4, 4, and 4. That's how I know where to exactly draw it. Same thing down with this semicircle. This is 2, and each of those radii would be 2 if I go use the center right there. So first thing I need to do is find all of my areas. So I know that I've got that the area will equal, I'm going to call it semicircle 1 plus semicircle 2 plus the rectangle. And I'm abbreviating everything just to kind of keep it shorter. So my semicircle, I know that a semicircle is half of a total circle, and the area of the circle is 4 squared times pi. My other one I know, again, is half of a circle, and that one has a radius of 2 squared times pi. And then my rectangle I know is length times width. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 by 1, 2, 3, 4, 5, 6, 7, 8. Now, if I go through and find my approximation, since I'm going to end up dealing with money, I would end up with, this would be approximately 39 and 3/10 square feet. This would be approximately 6 and 3/10 square feet. And this is 80 square feet. And so when I add them together, I would get about 125 and 6/10 square feet. Now I know my cost is going to be my area, 125 and 6/10 square feet, times, well, what's the cost per square foot? It's $3 per square foot. So that's $3, and then that's over square feet, and that's why my square feet cancel, leave me just with the cost. And when I multiply them together, I will get $376.80. Or I could say that that's about, which is probably more a better approximation, just be to say that it's going to cost me about $380 to make this patio.